Hello everyone and welcome back to my YouTube channel. In this lesson, we will continue from where we left off and we will do a little refactoring of our own custom JSON decoding function. Some people might call this premature optimization, but I disagree. Since this project could be a take-home project for a junior iOS developer position, a refactoring like this could very well lead to interesting discussions during the interview about your reasons for choosing a path for decoding different than the one proposed by Apple. Last time, we wrote our data models, and we came up with a main structure called API response, which contains a nested custom structure called current, which in turn contains an array of nested custom structures called weather. During development, we will populate these structures with data from sample JSON files we saved earlier in the app bundle, so that we can get real-life Swift UI previews. When the app will be finished, the data will come through the internet from a service provider called OpenWeather, based in London. We then learn what codable means and how to make our own custom structures conform to the codable protocol. We continued by learning about the decoding process, a process that takes data in the JSON format and converts it to a custom data structure. And we finished by creating our own decoding function, a function that takes the name of a resource JSON file and spits out an API response data structure if every of the three steps involved went well, that is. In this lesson, we will talk about enumerations, or enums for short, which will lead us to learn about a special new enumeration in Swift 5 called result. This new data type, I believe, will make our lives much easier when working with functions that can throw errors. We will then tackle issues regarding writing Swift extensions, ending up expanding some of the foundation data types with new functionality to fit our needs. And all of this will lead to us planning a new approach for our JSON decoding function we wrote last time. The function will do the same thing, but in a more interesting way, a little optimization, and we will discuss the benefits a little later. Ready to get started? Let's start by reviewing the function we wrote last time. It takes one argument, a string representing a file name for a resource somewhere inside the app bundle, but it returns an optional custom API response structure. Optional. I have a problem with that, and so should you. If the call fails, we get nothing, a nil, which contains no information at all about what happened, why it failed. Yes, the function is written to spit out some error information in the console, in just 2 out of the 3 possible cases where it can fail, but it does not return any error information to the caller, and that is just wrong. The decision of what to do with a possible failure should not be the responsibility of this function. The caller might decide to just ignore the failure, and that's fine, but it might very well decide to provide a clear explanation on the screen for the user, with instructions on how the user can try something else instead. It becomes clear that our function should not just return nil in the case of a failure, so an optional return type is not quite what we need here. Instead, our function should return either a valid custom structure or return error information in case of a failure, not nil. And there is a way to combine those two possibilities into a single data type. We will get to that a little later. The second problem I have is the code being inconsistent. If the code fails in step 1, we do not get any information in the console, because our function just returns nil without any printed explanation. But if the failure takes place in step 2 or step 3, then we get something more useful before returning nil. It will be in the console, so not available for the user, just for us, developers, which takes me back to my first problem. The error itself should be returned from this function and the caller should decide how to handle it. The third problem is code repetition. The way we handle failure in step 2 and step 3 are completely identical. That should be immediately considered a red flag. These failures, including the one in step 1, are completely mutually exclusive, meaning when one failure takes place, the code execution is stopped and the next steps are not even attempted. Handling the failure for any step should that be done in a single place and consistently. And my last problem is the code being so scattered. which is because of the nested do, try, catch blocks. For example, this line here, let data equals try data contents of URL, is attempting to perform step 2, where we have a valid URL and we convert it into a data buffer. But the section where we handle a possible failure for the same step 2 is way down here, below the entire step 3 section. In fact, we are dealing visually in code with failure in step 2 after dealing with both the success and the failure cases for step 3. We go from dealing with step 2 to dealing with step 3, and then dealing again with step 2 for the failure case. That is scattered code. It makes it much more difficult to review code later by either future you or someone else. I don't like it. I used to write code like this many times in my career, and I'm really getting tired of this style. Alright, enough complaining. How do we refactor our code to solve these problems? First of all, we will delete this entire code and we will rethink the return type for the function. Clearly, it should not be just an optional type anymore, because it does not convey enough information about possible failures. But what data type should we return instead? To answer that, let's take a look at a new data type in Swift 5 called result. Starting with Swift 5, the Swift programming language introduced a new type called result, which, according to documentation from Apple, is a value that represents either a success or a failure, including an associated value for each case. An enumeration, or enum for short, is a simple value type data that is defined to have different distinct cases. A variable or property of type enum can take the value of a single case at a time, because the cases are mutually exclusive. Take the example of a fruit enum, which might have a case for apple, one for cherry, and another one for peach. If we need to work with such a value, then we need to handle in code each case separately, and we do that with a switch statement. The execution for each case can be completely different from each other, depending on the app logic. Here, we just print something in each case to better understand the concept. But enums can have, if we want, associated values for some or all of the cases, and each associated value can be of a different type. An example of a veggie enum can look like this, with cases for carrot, potato, or eggplant. Carrot can have a string associated value for a color, potato can have a size as a double, and eggplant can have a brand as a string. We can switch on a veggie, just like we did on a fruit, but now for each case we can save the associated value that it carries, using a let or a var, and use that associated value during the code execution for each of the cases. The result value type is basically a generic enumeration with two cases, each with an associated value. One case for success, with some generic type as an associated value, and a second case for failure, with an associated type conforming to the error protocol. Since it is an enum, it means we can switch on a result just like on any other enum, fruit, veggie, or whatever, and in each result case, success or failure, we will have an associated value to work with. That includes the case of a failure, when we will get some error associated value. Perfect, that is exactly what we need. Instead of returning an optional type, meaning either a success or nil, we will now refactor our function and make it return a result type, meaning either a success or an error. We have to include between angle brackets and separated by a comma the types of the two associated values. For us, the return type will be a result of API response or error. As soon as we do this, however, the compiler will give us a warning, because last time we used our decoding function to test it in content view. And it was fine when our function returned an optional API response. But now we are returning a result type, and this type unfortunately does not come with a debug description computed property out of the box. We will have to make that happen ourselves. So let's just do that now before we go any further. The way of doing that is with the use of something called extensions. Extensions are used for adding new functionality to an existing type, such as a class, a structure, an enumeration, or even a protocol. This is exactly what we need, because we are dealing now with a result type, which we already know is an enumeration, and to which we want to add some kind of new functionality. What is great about extensions is that they can not only be applied to our own custom types, for which of course we have access to the source code, but we can write extensions even on types for which we do not have access to the original source, like for example, the result type. Perfect for us, isn't it? We want the new result type extended with new functionality, a debug description computed property. Here are some of the things that we can write extensions for in Swift. We can add computed instance properties. Perfect for us because the debug description is indeed a computed instance property. A computed instance property is a property that will exist on each instance of a class or of a structure. Computed means it does not store any value in memory, but it provides a value every time the property is accessed, kinda like a function. Extensions can also add computed static properties, not just instance properties. There's a difference between instance and static properties, but that will be for another video. We can also use extensions to define instance functions, and of course static functions on existing types. We can also provide new initializers, define subscripts, define and use nested types inside an existing type, and important for us today, we can make an existing type conform to a protocol. This is exactly what we will do to the result type today, because by adding an instance property called debug description, we will make the result type conform to a protocol. We will see that in a second. There are a few things, however, that we cannot do in extensions in Swift. We cannot override existing functionality, and we cannot add more storage to an existing type. Alright, let's see an extension in action. In a new file, let's call it result plus extension.swift. Let's write an extension to result. In order to get what we want, we will make the result type in general conform to the protocol custom debug string convertible, which is simply a protocol that provides a type with a customized textual representation suitable for debugging purposes. That's what we need for our test, and that's what we already had last time by default on any optional type. We want the same ability to exist on a generic result type. In order to conform to this particular protocol, we need to implement a public computed property called debug description, which of course will return a string. The implementation of the debug description will depend on the result itself, which has two distinct cases, so let's switch on self in here. Wait a minute, switch on self? What is this self? Well, the context here is that we are inside an instance of a generic result, so self is a result type, which remember is simply an enumeration, and like any enumeration we can switch on it in order to conditionally execute different code for each of the possible cases. There are two cases in a result enumeration, case success and case failure, and each case comes with an associated value, which we can extract locally inside a switch block, like we did with a veggies enumeration earlier. So what to do in case of success? We will return a string, a concatenation of the constant string success and the extracted success value converted to a string. We can use the plus operator here to concatenate strings together. The first part is a constant string, but the second part is something called a string interpolation, indicated by a backslash followed by some object name inside parentheses. String interpolation takes the object inside a parenthesis, for us the locally extracted success associated value, and converts it into a string representing a textual description of the object itself. A computed property needs to return something, and that is why I compared a computed property with a function earlier. All functions return a value, and so do computed properties. In the failure case, we do something similar. We return a string concatenation of the constant string failure plus the description of the error, which we get locally here as an extracted associated value for this second enumeration case. Now that we have extended the result type so that each instance will have its own debug description property, and we got rid of the error in the content view, let's design a plan for a new approach for our JSON decoding function, so that our function this time will return a result value instead of an optional custom structure. We will start by remembering the steps involved last time. We had to start with a string which represents a file name, and we use the bundle.main.url for resource with extension instance call to convert that string into a URL. That call returns an optional URL, which means either a valid URL or nil. Then we had to feed a valid URL to an initializer for a data object with contents off. This is a failable initializer, meaning it either returns a valid data object or it throws an error. We then continued by feeding a valid data object to a new instance of an JSON decoder object, on which we called decode from. This was the third and last step, returning either a valid API response structure or throwing another error. If we want to use the new result type, we will need to make a few small changes. We are still going to start with a string representing a file name, but we are not going to call the URL for resource with extension. Instead, we will write our own function, similarly called URL result for a resource with extension, which will still be part of the main bundle. I added the result word to the function name. We can do that with the use of extensions again. We just finished extending a generic result type to have a debug description property. We will do the same here and extend the bundle class to contain a function called URL result for resource with extension. This new function will return a result type of either a valid URL or an error. If we do have a valid URL, instead of using data contents of like last time, we will write our own function. Let's call it result contents of, which we can create as a static function on the data class. More about the meaning of a static function at a later time. And we will make this function return a result type also, a result of either a valid data or an error. I hope you are still with me. We only have one more step to go. When we do have a valid data object, we will feed that to our third custom function. But instead of using the decode from function on a new JSON decoder instance, we will create our own decode result from function, which will still be an instance function on a JSON decoder object. And this one will produce our desired return type, a result type of either API response or an error. As a result to our custom functions we will write in extensions, our previous decoding function, which used to be very inconsistent and full of do, try, catch blocks, will be seriously simplified. It will start with a call to our own URL result for resource with extension on the main bundle, and we will immediately feed the result to another custom extension function call on data, one that we will write later on. Lastly, we will take the result from the data call and immediately feed it to a new instance of a JSON decoder object, calling a function that again does not exist yet, but it will when we will write an extension on JSON decoder. And this last call will produce the desired return type for our decoding function, a result of either a valid API response or an error. One cool side effect of writing our decoding function this way is that the function will contain a single line of code. That's right, it appears to be 3 lines of code, but in fact it will be a single line of code, spread on 3 lines only due to being too long and not fit on the screen. In fact, we did see this before in the content view that was provided by default when creating the Xcode project. The text subview with a padding call after it is in reality a single line of code, but appears to be written on 2 lines of text. Our function will, similarly, make 3 separate calls, which will be chained together in a single line of code by using the dot notation. I invite you all to come back next time to see how we will make these changes to our codebase. We will continue by creating some new extensions like we did on the result type itself, an extension on bundle, one on data, and one on JSON decoder. Then we will even learn to create our own custom error. Remember the last 2 steps in the JSON decoding process come with their own errors, which are thrown at us and we need to deal with them. But the first step just returns nil, in case locating a resource file fails, which is not right. We will create our own custom error to be consistent. When we have these pieces, we will refactor completely our decoding function, ending up with a single line of code. And if we have some time, we might even start writing our first Swift UI subview. With that being said, I hope to see you all in the next lesson.